Hello everyone, today I'm going to be going into a topic on the ACT math portion of the test. The topic is algebra problems with restrictions. I've had a couple of students approach me and ask me, what do I do with restrictions on these algebraic problems that I see on the test? Should I even concern myself with them? And if so, how do I apply them on the problems that I'm doing? Okay. And with the limitation on time that students already have on the ACT test, what is the fastest manner to approach these? So I'm going to give a couple of examples here and go through them and give a step-by-step process on how to quickly finish up these problems on the test. Okay. So example 1, you'll notice the restriction immediately. I'm going to post it here on the board in a second. Yeah, so you should see in the problem itself, you'll notice if xy cannot equal x. So what I like to do with the restriction is I blockade it off from the rest of the problem. Okay, and there I've created a wall, separated it, and look at only the algebraic expressions given. So the first one is y equals 1 over x, and the second algebraic expression is 2 times 1 over x divided by y minus 1. Alright, there's a much better circle. That way I'm not canceling out any of the numbers there, losing visual. Okay, so there are 2 steps basically in these types of problems. The first one that I always tell students is substitution. Okay, substitution can be used for equations with similar variables. Okay, so I see a y here, I see a y here, I see an x, and I see an x in both equations. Okay, so both equations have the same variables being used. So substitution is the first step, and the second step is simplifying. Okay, now simplification involves a couple of things. Now when I say simplify, it means to factor. Okay, that's one of the small areas, okay, that you need to concern yourself with is factoring. And the second thing is condensing. Now when I say condense an expression, that means to bring like terms together and then use division, subtraction, whatever it is in the problem, and combine everything and compress it to as small as you can get it to the expression, okay? Bringing everything together. So let me get rid of this final step here. I'm going to start with substitution in this problem. Okay, so I see that y equals 1 over x. I take the simplified expression, the one that's the smallest or the compressed one, and I substitute it into the expanded expression. So in this case, I'm going to change the color here. Okay, so it's easy to see this step in the process. Step 1, substitution. So you do 2 times 1 minus x over y minus 1. Now y is being substituted for, so it's 1 over x minus 1. Okay, so I brought this and I substituted in for the y term here. Okay, now the second thing that I want to do as soon as I'm done substituting is combining terms. Okay, now I want to combine terms on the top and on the bottom, so I'm going to start with the bottom here. Okay, because I have 2 separate terms here, and the way to combine them is you must have a common denominator. When you subtract terms that have fractions, you must have a common denominator. So in order for the 1 to have the same denominator here, what I'm going to do is multiply the top and bottom by x, because x is already here as a denominator, so I'm going to multiply 1 by x over x. Okay, and the top remains the same. Now what I can do in my next step, okay, let me change the color again here. Okay, we'll call this step 3 here. Okay, I'm going to take 2 times 1 minus x, leave the top alone, and condense the bottom. Now the way I condense it is combining the terms, so 1 minus x over x. The denominator remains the same when I'm subtracting terms. My fourth step in this process is going to involve, now I have the top term divided by the entire bottom term. Now when you're dividing by a fraction, it's the same thing as multiplying by the reciprocal. Okay, so in this case what I'm going to do is I'm going to do 2 times 1 minus x, okay, times x over 1 minus x. Okay, in this case, now the last step in this process, step 5, what I'm going to do here is cancel out the like terms, and I'm left with 2x. Okay, so that becomes my final answer. We're going to put it in green over here, and 2x is my final answer by compressing the terms. Okay, so h is my answer. Now a lot of times what people do is spend so much time on the restriction or worrying about it that they forget about the rest of the problem. What they're really asking when you have algebraic expression is to substitute and simplify. Okay, that's it. Substitute, simplify, disregard the restriction given to you in the problem, or else you'll just be wasting unnecessary time on these types of problems. Okay, let me give you a second problem here. All right, that doesn't involve two expressions, but only one expression. Let me bring up a new page. Okay, and let me expand this page a little bit. All right, perfect. Okay, so it's in, yeah, it's in the frame. All right, so the second problem I'm going to give here, okay, problem 2, states if P does not equal Q, then for what values of R, meaning the variable R, is the following inequality true? Okay, now when I say the following inequality, I'll be listing it below this problem. Alright, so there's our problem. Okay, if P cannot equal Q, then for what values of R is the following inequality true? Now the inequality, I'm going to change the color here. We're going to make it RP minus RQ over 3P minus 3Q is less than 0. All right. Now, when I'm looking at this, I want to always apply the first step that I taught you guys in the last problem, guys and girls, okay? And that was to separate off the restriction overall, okay? I'm going to blockade off the restriction and not worry about it, okay? So there it is. I'm going to take it out. Don't worry about it at all. I'm going to take my equation here. I only have one equation, one inequality here. So I cannot substitute, but I can simplify. And if you remember when I talked about simplifying, factoring and condensing, okay? That's very important. So when you simplify, factor, and condense, I can pull out the R. Let's change the color here again. Okay, so let's make it a blue. So I can take out the R out of the top if I'm factoring. And then I can take out the 3 out of the bottom if I'm factoring. I'm looking for a common factor on the top and bottom. Okay? And when I do that, I notice that P minus Q is common on top and bottom. Okay? That means in my next step, I'm going to be left with R over 3 is less than 0. Okay? And in that case, what I want to do is go to my final step here, step 3. Okay? Let's make it a little bit darker in terms of the green. Okay, so it becomes an algebraic expression. I can multiply both sides by 3. Okay? So I'm left with then R is less than 0. In that case, a possible answer could be all real negative numbers. R is less than 0, meaning all real values less than 0 work out. Okay, so that's where I got the negative values from. So these are the two problems that I wanted to show everyone in terms of the restrictions, algebraic problems on the test, on the ACT test. If anyone has any questions or inquiries, feel free to check out the link at the bottom of this video. I can be contacted at the link below, so feel free to check this out, and I'll be posting more videos coming up about other topics in the ACT math and other parts of the ACT test too. All right, thanks a lot everyone for listening today.